Hello, students. Your exams are coming up very soon, I know. So let's just take a moment, take a nice deep breath, and let's revise the very first chapter of your chemistry syllabus, chemical reactions and equations. We'll go through it all, step by step, making sure all the concepts connect so that you feel absolutely confident for your exam.
So here's what we're going to cover today. First, we'll touch upon the basics. What is a chemical reaction? Then we'll learn how to write them down using chemical equations. After that, we'll practice a very important skill, balancing those equations. Then we'll get into the different types of reactions. And finally, we'll wrap up with a handy checklist for your exam.
All right, let's begin. So what is a chemical reaction? Well, it's quite simple, really. Whenever a chemical change occurs, we say a chemical reaction has taken place. You see them everywhere. Think about milk turning into curd, or the food you eat getting digested, even just rusting of an iron nail. These are all chemical reactions happening all around us every single day.
Okay, so how do we know for sure that a reaction has happened, especially in the lab? We look for certain signs or indicators, and you absolutely need to remember these four for your exams. Did you see a change in state, like a solid disappearing? Was there a change in color? Did you see any bubbles, which means a gas is evolving? Or did the beaker get hot or cold? These are the clues, and they are so important for your practical-based questions.
Now, seeing these changes is one thing, but in chemistry, we need a simple, standard way to write down what's happening. And that's where chemical equations come in. You can think of it as the language of chemistry.
The simplest way to start is with a word equation. It's exactly what it sounds like. We just use the names of the substances. So here, we have magnesium and oxygen on the left side. These are our reactants. The arrow shows that they react to produce our product, magnesium oxide, which is on the right. Very straightforward.
But writing out full words is a bit long, right? So to be more scientific, we use chemical formula. This is called a skeletal chemical equation. It's much shorter. But take a careful look at this one. Do you spot a problem? On the left, we have 2 atoms of oxygen, but on the right, we only have 1. This means the equation is unbalanced. And in chemistry, that's just not allowed.
And that brings us to a very fundamental question, one that you might get in your exam. Why? Why is it so important that a chemical equation must be balanced? Think about it. What is the basic law of science that this is all about? The answer, of course, is the law of conservation of mass. This law tells us that in any chemical reaction, atoms are not created or destroyed. They are simply rearranged. So the number of atoms of each element has to be the same on the reactant side and on the product side. It's as simple as that. That's why we balance.
Okay, so we know why we have to balance, but now we need to learn how to do it. We're going to use what's called the hit and trial method. Now, don't worry about the name. It's actually a very logical, step-by-step process. With a little bit of practice, you will find it very easy.
Let's try to balance this equation, which is a very common example from your textbook. We have iron, that is Fe, reacting with water, H2O, to form Fe3O4 and hydrogen gas, H2. Just by looking at it, you can see it's unbalanced. There's 1 iron on the left and 3 on the right.
So let's follow the steps. Step 1, and this is the most important rule. First, draw a box around each formula. You must remember that you cannot change anything inside the box. After that, make a list of atoms on both sides. A good tip is to start with the biggest, most complicated compound. Here, that's Fe3O4. Balance the oxygen first, then the iron. Then move on to the other atoms one by one until every single one is balanced.
And there you have it. After following the steps, this is our final balanced equation. And you can see from the table, we now have 3 iron atoms on both sides, 8 hydrogen atoms on both sides, and 4 oxygen atoms on both sides. Now it's perfectly balanced. Now, if you want to write a perfect equation and get full marks, there's one more little thing you can do. You can make it more informative by adding the physical state symbols. We use S for solid, L for liquid, G for gas, and AQ for an aqueous solution, which just means something is dissolved in water. You can also mention conditions like temperature or pressure right above the arrow.
Excellent. Now that we know how to write and balance equations, we can start putting them into categories. We classify reactions based on what is actually happening to the atoms. This is a very important topic for your exams, so let's focus here.
The first type is the easiest one to spot. It's called a combination reaction.
The name says it all. Two or more reactants combine to form just one single product. So if you see an equation that looks like A plus B gives you C, you know it's a combination reaction. And here's a classic example. Calcium oxide, which is also called quicklime, reacts with water. And what did they form? One single product, calcium hydroxide, or slaked lime. You might have also noticed that this reaction produces a lot of heat. Any reaction that releases heat is called an exothermic reaction. All right, next up we have the exact opposite of combination. This is a decomposition reaction. Here we start with one single reactant, and it breaks down into two or more simpler products. So the pattern is A breaks down to form B plus C. And usually these reactions need some form of energy to make them happen. And that energy can be supplied in different ways. If we use heat, it's called thermal decomposition. If we use electricity, it's called electrolytic decomposition. And if we use light energy, it's called photolytic decomposition. Let's look at two important examples from your textbook. For thermal decomposition, we have limestone being heated. For photolytic decomposition, we have silver chloride. An important observation to remember here is that the white silver chloride turns gray when you keep it in sunlight. This reaction, is actually used in black and white photography. We've covered a lot today, haven't we? So to make sure you have everything clear in your mind, let's just go through a quick final checklist. Think of these as the most important things you must know from this part of the chapter before you go for your exam. Okay, here it is. Ask yourself, do you remember the 4 indicators of a chemical reaction? Can you explain why equations must be balanced? Are you comfortable with the hint trial method? Do you know how to write the physical state symbols? And finally, can you define combination and decomposition reactions and give at least one example for each? If you can say yes to all these points, you are doing very, very well. So with this revision, I hope you feel that you've connected all the important ideas from the chapter. You have the knowledge, you know the methods, you are ready to tackle any question from this chapter with full confidence. I know you are. All the very best for your exams.